Welcome to another video by Adeptis Academy. Take a moment. Look around you. Consider the invisible world constantly surrounding you. Silent signals dance through the air, carrying messages across vast distances. This is the world of radio frequency, or RF, underpinning modern technology. It's like an invisible orchestra, playing a symphony our lives depend on. From checking your phone to hearing the weather forecast, you're constantly experiencing this unseen orchestra. Radar lets us see without eyes, revealing what's hidden. Radar guides airplanes, tracks storms, and keeps our highways safe. RF is the communicator, radar is the scout. Both rely on electromagnetic waves, powering our daily lives. We'll explore how these technologies work, using simple explanations. You'll gain a newfound appreciation for the brilliant symphony playing around you. Let's begin our journey into this invisible world. What is radio frequency, or RF? It's a fundamental part of our modern world, underpinning so much of what we take for granted. From radio broadcasts to satellite communication, RF is the invisible force at work. Imagine ripples spreading outwards. These are a visual analogy to how RF works. RF waves travel through air and space. They are a form of electromagnetic radiation, propagating outwards from a source, carrying information across vast distances. These waves are perfect for carrying information over long distances, making them ideal for broadcasting signals across cities and countries. RF powers car radios and Wi-Fi, which connects our devices to the internet. Each radio station has a specific frequency to transmit its signal. Your device tunes into just one, ignoring the rest, allowing you to isolate the signal you want. This system lets countless signals share the same space without getting mixed up. We attach voices, pictures, and data to these waves, modulating the RF signal to encode information. When you speak into your phone, your voice is converted into a digital signal. This digital code then rides a radio wave, being modulated onto the carrier frequency and instantly sent. Your Wi-Fi, car key fob, and garage door opener all use RF, simplifying our lives. RF is the invisible thread connecting our devices, creating a seamless web of communication. It's the steady heartbeat of our interconnected society, the pulse that keeps our digital world alive and functioning. Now let's meet RF's amazing cousin radar. This technology is a cornerstone of modern navigation and surveillance, and it's all thanks to radio waves. Radar is short for radio detection and ranging. It's a clever acronym that hints at its core function, using radio waves to detect objects and determine their range. Imagine shouting in a dark cave, your voice echoing off the unseen walls, and listening intently for the echo to find the wall, gauging its distance and perhaps even its shape. This is the basic principle behind how radar works, but instead of sound, it uses electromagnetic waves. Radar does this with radio waves, a form of electromagnetic radiation. It sends out a pulse of energy, a focused burst of radio waves emitted from an antenna. If it hits something, an airplane, a ship, or even a raindrop, some of that energy bounces back as an echo. This echo is the key to radar's ability to see. By precisely timing how long the echo takes to return, the radar system can calculate the distance to the object. Radar measures distance with incredible accuracy, often down to mere centimeters, providing a precise location. Radar can also tell us about an object's size and location, giving us a more complete picture of what's out there. All this is achieved by carefully analyzing the strength and direction of the returning echo. Stronger echoes indicate larger objects, while the angle of the returning signal reveals the object's direction. Rotating antennas scan the sky, methodically sweeping across the horizon. This creates a 360-degree map, constantly updating with new information. It's like painting pictures with invisible light, revealing what our eyes cannot see. This superpower lets us track airplanes, ensuring safe air travel. It allows us to see inside storms, predicting their path and intensity, and it helps ships navigate safely through fog, preventing collisions in low-visibility conditions. Radar is our set of eyes for the unseen, constantly monitoring the environment around us. It transforms invisible waves into clear, useful information, providing critical insights for decision-making. It reveals hidden worlds, unveiling objects and phenomena that would otherwise remain hidden from view. This is especially crucial at night or in bad weather, when visibility is severely limited. With radar, we see what's otherwise invisible, gaining a significant advantage in various situations. Ultimately, radar is about making our world safer and more understandable, providing us with the information we need to make informed decisions. It's a technology that truly extends our senses, allowing us to perceive the world in ways we never thought possible. Radar's story began with a series of discoveries, not a single invention. In the 1880s, Heinrich Hertz proved invisible electromagnetic waves existed and could bounce off objects. At first, it was just a fascinating experiment until the early 1900s, when the world needed ways to detect distant threats. Christian Holzmeier built a device in 1904 that could detect ships in fog using radio echoes, planting the seed for radar. The real breakthrough came before World War II, when Robert Watson Watt's team in Britain built the chain-home system to spot enemy planes from over 100 miles away. This early warning system was crucial in the Battle of Britain. After the war, radar found peaceful uses tracking weather, managing air traffic, and making flying safer. Weather radars let meteorologists see storms forming miles away. What started as a tool for defense became a technology of safety and discovery, quietly changing our world. Radar's journey is a testament to human curiosity and ingenuity. Radar isn't just for the military or airports. It's part of our daily lives. Air traffic controllers use radar to track every plane, guiding them safely through the skies. Weather radar shows us where rain and storms are, helping us prepare for severe weather. Police use radar guns to measure car speeds, encouraging safer driving. Modern cars use radar for adaptive cruise control, keeping a safe distance from other vehicles. Ships navigate through fog with radar, and even space probes use it to map distant planets. Radar is a silent guardian, making our world safer and more orderly. It's everywhere, working behind the scenes. How does radar turn invisible echoes into a picture? It's all about timing, direction, and strength. First, radar sends a pulse and measures how long the echo takes to return. This gives distance. Next, the antenna focuses the beam and knows its direction, so it can pinpoint where the object is. The strength of the echo reveals the object's size or intensity. A big plane sends a strong echo, light rain a weak one. Weather radar uses color maps, red for heavy rain, green for drizzle. By combining timing, direction, and strength, radar builds a detailed map of its surroundings. The antenna sweeps the sky, collecting thousands of data points every second. Computers turn this data into dots, shapes, or colors on a screen. It's a beautiful process, turning invisible signals into clear, visual information. Radar helps us see the world in a whole new way. Radar has another trick. It can hear movement using the Doppler effect. Just like a siren changes pitch as it passes, moving objects change the frequency of radar echoes. If something moves toward the radar, the echo's frequency rises. If it moves away, it drops. Doppler radar measures these tiny shifts to calculate speed. This is how police radar guns work. Weather radar uses this to see raindrop movement, detecting storm rotation and spotting tornadoes before they're visible. This ability saves lives by giving early warnings. Doppler radar adds a new dimension, velocity, to radar's vision. It's a brilliant use of physics in everyday safety. RF and radar are evolving fast, with new uses emerging all the time. Tiny radar chips are now in smartphones and smart devices, sensing gestures and monitoring health. Quantum radar, using principles of quantum physics, could one day detect even stealth aircraft. Self-driving cars rely on advanced radar to see in all conditions, keeping us safe on the road. RF technology is powering faster networks like 5G and soon 6G, connecting everything from appliances to city lights. These advances will enable immersive experiences and smarter, more connected lives. The invisible orchestra is growing richer, making our world more intelligent and responsive. The future of RF and radar is just beginning. Why does this invisible world matter? Because it's the foundation of modern life. Understanding RF and radar helps you make sense of the technology you use every day. It empowers you to engage in conversations about new networks, air safety, and innovation. This knowledge sparks curiosity and wonder, reminding us there's more to reality than meets the eye. The air around you is alive with information, connecting us all. Next time you use your phone or check the weather, remember the invisible orchestra at work. You now understand the secret language behind these signals. This insight connects you more deeply to our brilliantly engineered world.